The contract curve in an Edgeworth box is defined as a set of allocations that represent efficient allocations. In other words, a set of allocations such that if we end up at that allocation, there's no way to make one party better off without making the other worse off. We'll illustrate here how we can derive such a contract curve. Let's begin with some arbitrary indifference curve from my indifference map. Not necessarily the one that passes through an endowment, but just any indifference curve from that map. We can then also illustrate a second indifference curve that intersects my blue indifference curve, and that represents one of the indifference curves from my wife's map. We know from our work in the previous graphs that the shaded region between these indifference curves represents allocations that are preferred by both me and my wife to either of the allocations that lies at the intersections of these indifference curves. Imagine then holding fixed my indifference curve and asking how high an indifference curve can we reach for my wife and still make sure that I get the blue indifference level. As we move to high indifference curves for her, we eventually end up at a tangency like that at allocation C. This allocation C is then one possible efficient allocation, an allocation where our marginal rates of substitution are the same, and any deviation from C makes at least one of us worse off. But since our choice of the initial blue indifference curve in panel A was arbitrary, we just picked one possible indifference curve from my map of indifference curves, we could pick some other blue indifference curve and go through exactly the same exercise, again finding the point of tangency between the blue and the magenta indifference curves. Thus we can find many different allocations within the Edgeworth box where the efficiency condition holds. In other words, many allocations where if we end up at that allocation, there's no way to make one of us better off without making the other worse off. The set of all efficient allocations in the Edgeworth box is then defined as the contract curve. This contract curve has to logically run from the lower left-hand corner of the box to the upper right-hand corner. At the lower left-hand corner, for instance, I own nothing and my wife owns everything. In that case, any deviation from that point causes her to become worse off and me to become better off. Thus, there is no way to make both of us better off, or to make one of us better off without making the other worse off. The corner point is therefore an efficient allocation, as is the other corner where I own everything. One of the lessons of developing the contract curve in the Edgeworth box is that it clearly demonstrates how efficiency has its limits as a normative concept. Just because something is efficient may not mean that we think it's good. We may not think it's good that I own everything while my wife owns everything, yet these allocations are indeed efficient. The contract curve contains lots of efficient allocations, where all gains from trade have been exhausted. But we might view some of them as better than others. We might think it's fairer for both me and my wife to have some oranges and some bananas, rather than giving everything to just one person, for instance.